Hello students, this is Mrs. Cindy and I'm here to talk to you today about the least common multiple. I have a little bit of a cold if you can tell. Okay, let's start off with this great example and you guys can see the example. So let me skip ahead to the relevant section. Okay, we'll stop there. But you get the idea, okay? What we're going to do is we're going to figure out how many hot dog buns and how many hot dogs Steve Martin could actually use in order um, to solve this problem for himself. Okay, so what we could do when we do this is let me just get myself into screen. Oops. So what we could say is something like if he had the hot dogs, right? If he was buying hot dog packages and then also bun packages, right? If he bought one hot dog package, he would get 8 hot dogs. And if he bought one bun package, he would get 12. So let's try to figure out how many of each he has to buy in order to have an equal amount. Okay, if he bought 8 more, he would have 16. If he bought another package, he'd have 24. If he bought another hot dog package, he would have 24. And gee, that seems to be the common number between the two. So if he bought 3 packages of hot dogs, 2 packages of buns, he would end up with 24 matching, right, pairs of hot dogs and buns. Okay, so that's what we're doing. That's what the least common multiple is, and that's what we're working on today. Okay, so let's talk about the different ways that we can solve it. There are really 2 methods, but let's define our terms first. But let me change color because I'm a big fan of the yellow color. Unfortunately, sorry to put anybody down. Okay, so least common multiple, another way to say this is LCM. This is our shorthand or our acronym. Okay, it is the least, this is a terrible definition, common multiple of 2 or more numbers. So let's break this definition down a little bit. Okay, so least is the smallest. Okay, and then common multiple. So let's define multiple first, and then we'll define common multiple. So a multiple is a product of a number and any whole number. Okay, a common multiple is defined as multiples shared by 2 or more whole numbers. So multiples shared by 2 or more whole numbers. Okay, so let's do some examples so it can be super clear for us. Okay, and so the definitions may not be good, but these examples will be great. Okay, so there are 2 methods really that we can do this. Okay, the big question is to find the least common multiple between 8 and 12. So method 1, and let's go through a couple of examples like this. So method 1, okay, is to list the multiples. And this one works just fine. You know, both of them are good. I find that the second method is more tricky. You kind of have to remember it. But once you've done it a few times, I think it's really good. Your homework, you're going to be asked to do both. Okay, so you're going to be asked to do both all the time. So the first way you list multiples, so in this example, we have the number 8 and we have the number 12. And what we do is we just kind of list them. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. And it keeps going. We may be done, we may not be done. Okay. 12, we would go 1 times 12 is 12. We'd go to 24. We'd go to 36. But if you see, we've already hit a common multiple. There's already a number that both numbers go into as a product. Okay. So the question in method 1 is, when do you end? Because this list can go on infinitely, right? So when do you end? And really the answer to that is going to be, you extend the list until you find a multiple common to all numbers you're searching for. Okay, and so with that said, how do you know? How would you know to stop here? And so you could do like 3 up here and then 3 down here and then keep going, extend here. So this is kind of a tricky part of when do you end. Okay, let's look at another example or method. Let's look at another example of method 1. That's what I was trying to say. So let's say that we want to find the least common multiple, not of 8 and 12 now, but instead of 6, 9, and 12. Okay, so we would write 6 here, 9 here, and 12 here. So 6, we go 6, 12, 18, 24. Let's stop there. Let's do 9, 18. 18 is pretty good. And then you go up to 27, and then 36. Okay, we've done 4. 18 and 18 are pretty good. And then we have 12. We have 24. We have 36. Oh, so 36 and 36. Let's see if 6 goes into 36. So 24, and then 30, and then 36. So there you go. Okay, so kind of a more methodical way of finding it. But 36 would be your least common multiple for 6, 9, and 12. Okay, so remember those. They're in your notes now. And let's look at the other method with these same numbers. So find the least common multiple of 8 and 12. And method 2, what we're going to do is we're going to use prime factorization, which is, kind of what we've been doing this whole time. So we're going to use prime factorization here. And what it is you list the prime factors. So you kind of have a part A to this. So you list your prime factors of these numbers. So I'm going to just go ahead and not do the factor tree. I'm going to list the numbers. So 8 and 12 is what we're focusing on in our first example. And so I know that 8, when it's the prime factorization of 8 is 2 times 2 times 2, and 12 would be 2 times 2 times 3. Okay. Now, what you do, this is a tricky definition, okay, and I can't think of another way to explain it, and so just write this in your notes and then look at our example, okay? So the next kind of instruction, part B, I guess, would be to write each factor the greatest number of times it appears in the prime factorization. And then step C, I guess, would be, and then multiply. So let me show you what this part means. This part B means, and I'm going to use a different color, honestly, just to keep it real. so here, so it's saying write each factor the greatest number of times it appears. So the two factors that came out of the prime factorization of 8 and 12 were 2's, right? 2's are on both. And then there's a 3. So the greatest number of time you're seeing the 2's is 3 times from the 8. And so this is part B, where you write it out, where you see it the most commonly. And then, so 2, right, there's 3 versus 2, you know. And then the other number that is present, the other factor that's present is 3, and it's only shown once, okay, so you write that there. And so if, and then you multiply. Step C is to multiply. So 2 times 2 times 2 is 8, times 3 is 24. And as you recall from our last example, 24 was the least common multiple for 8 and 12. Okay, so let's do the same thing with our next example of, you already know, but 6, 9, and 12. So let's try this second method, do for 6, 9, and 12. So for 6, you would say that the prime factorization was 2 times 3. For 9, you would say that the prime factorization is 3 times 3. And for 12, you would say that it's 2 times 2 times 3, okay, or 4 times 3. So which ones, so the only two prime factors are 3 and 2, and in which ones are they present the most? So I'm seeing 2 3's here. So I will write 3 times 3 for our step B. And then I'm seeing 2 2's here, 2 times 2. So 3 times 3 is 9, times 2 is 18, times 2 is 36. And as you know, in our first method, we had found that 36 was the least common multiple for both of these. Okay, so these are the two methods, and I have to say, if I remember this is my favorite one, okay, when I remember it. The other way is very methodical, and it works just as well. But this really feels like a shortcut, which I like. Okay, so let's move on to how we can use this information, and this is kind of, we're working on fractions ultimately, so let's see how this can help us find the least common denominator in fractions. Okay, so this is shorthand, the acronym for this is LCD, in fractions is what we're doing. It's just, that's an R that's missing, sorry, that's hidden. So for example, let's go ahead and use 3/8 and 3/5, and our assignment is to find the least common denominator. And so all we're going to do actually is we're going to focus in on this 8 and this 5. Okay, so 8 and 5. What are the least common denominators, or the least common factors between 8 and 5? So we can do it one of two ways. Again, there are the two methods. We could increase this by, you know, keep adding 16, 24, 32, 40, and then let's stop there. And then here would be 5, 10, 15, 20, 25, 30, 35, and I know you've already guessed it, 40. So 40 and 40 is the least common denominator here. And so all you would actually write as your answer is the least common denominator equals 40. Okay, we aren't going to put it back in the fraction yet. We'll practice that later. But then to revisit our other method, between 3/8, oops, I don't know why that's happening, 3/8, and what I say, 3/5. Okay, so again, 8 and 5. We could do the prime factorization, so 2 times 2 times 2. This is just 5 times 1, basically. So where does it come up the most? The most frequent is 2 times 2 times 2 times 5. And in this case, that is 40. Okay, so, so you would get the same answer with both methods. Okay, one more example, and then we'll say go ahead and practice. So 9/14, 1/8, and 4/7. And I'm going to go ahead and do method 2, just because it's so much faster, honestly. So 14 would be 2 times 7. 8 would be 2 times 2 times 2. And 7 would be 1 times 7, basically. 1 times 7. And so the most present that they are is 2 times 2 times 2. And then that's where the 2's are the most present. You can put the 1 in, but it doesn't make a difference. And then there's only 1 7 in both of these, so you could do times 7. So 8 times 7 gives you 56. And as it turns out, 14 also goes into 56 if you wanted to check it, right? So you would do like 14, 28, 42, and then 56. So as it turns out, it is if you wanted to look back at your method 1. Okay, enjoy practicing your homework.